Okay, problem 2. Compute the following iterated integrals. Change order of iteration if necessary. Okay, for y from 0 to 1 and for x from y to 1. Right, e to the power of x squared dx dy. Okay, so why do we have to change the order of integration? Because if we try to just integrate this, you will find that this part is very, very hard to integrate by x directly. Okay, then how do we change the order of integration? Can you simply just switch them? No, it doesn't work. Okay, why it doesn't work? Because every double integration, it is actually describing a certain region. Okay, so what is the region that is described by this double integration? We can draw it. Okay, it's x, y. It's for x, so it's always reading from outside to inside. So outside, it's for y from, right? It's for y from 0 to 1. Okay, for y from 0 to 1. And what about x? So its x is from, right? It's from y to 1. Okay, it's from y to 1. So what does that mean? That means for any y, for example, I fix y to be here. Then my x, okay, then my x, for example, when my y is 0.5, then my x is from 0.5 to 1. Okay, when my y is 1, my x can only be 1. When my y is 0, my x can be from 0 to 1. Okay, so you can see for a given y, your x is actually from at y is equal to x, which is this line, right, to this part. Okay, so it's actually this entire region. Okay, it's this entire region. So how can you describe this region in another way? So now it's for y from 0 to 1, right? X is between. So we can describe it for x from, right? For x from 0 to 1. What about its y? For x from 0 to 1, its y is from here to here, right? Its y is from 0 to x. For x to be here, its y is from 0 to x. Okay, so its y is from 0 to x. Okay, so that's why we can rewrite this double integration as for x from 0 to 1, so for 0 to 1 dx, its y is from 0 to x. Okay, its y is from 0 to x, e to the power of x squared. Okay, so now it's much easier to integrate because here we integrate this by y, then no matter how complicated it is, we just treat it as a constant. Okay, so it's just e to the power of x squared times y for y from 0 to x. Okay, so you can just do the substitution. It would just be x times e to the power of x squared dx. Okay, now you can do the substitution, right? And it's going to be much easier. So it's u is x squared, du over dx is 2x. So what? So your x times dx is half du. Okay, so this is, okay, now x is 0, u is x squared. So it's 0 squared, 1 squared. X times du, it's half du. Okay, e to the power of u. Okay, so which is just the integration from 0 to 1, half, put it outside, e to the power of u du. Okay, so it's just half e to the power of u from 0 to 1. Okay, so you can get the answer. Okay. Alright, so then let's do part B. Part B, the double integration is this. Okay, again, if you try just to integrate this by y, it's very, very hard. So similarly, let's draw the region that is described by this double integration first. Okay, so for x from 0 to 1, its y is from square root of x to 1. Okay, so y is equal to square root of x, which is this. Okay, this is y is equal to square root of x, okay, to 1. Okay, so the region described by that is this part. Okay, then you have to redescribe this region. Okay, how can we describe this region? So for x, right, so before it's for x from 0 to 1, now it's for y from 0 to 1. Its x, right, is from, okay, you can see for each y, its x is between here and here. So its x is from 0 to this part. Okay, what is this part? The y is square root of x, so the x is y squared. Okay, so it's from 0 to y squared. Okay, that's why you can rewrite this as for y from 0 to 1, its x is from 0 to y squared. Okay. Then 3 over 4 plus y cubed. So now it's, wait, let me write it down here. Okay. So now, if you integrate it by x, then no matter how complicated this part is, it's very easy, right? Just replace it by x. So it's 3x over 4 plus y cubed for x from 0 to y squared. Okay, so it is from 0 to 1, 3y squared over 4 plus y cubed dy. Again, now the substitution is much easier. You can just let u to be y cubed. So du over dy is 3y squared. Okay, so 3y squared times dy is du. Okay, so here it is u is y cubed, and this part is du, 1 over 4 plus u. Okay, 1 over 4 plus u. So it is, okay, so the integration is just lowering 4 plus u, all right, for u from 0 to 1. Okay, so it's just lowering 5 minus lowering 4. Right.